Another Leetcode problem. 23, 45, 54 number of excellent pairs. So for this problem we are giving a nums array and we are also giving an integer k. So it is from 0 indexed positive integer array. So a pair of numbers nums1 and nums2. So this means we're gonna choose two numbers from the nums array. So it is called excellent if the following conditions are satisfied. So the first condition is that the nums1 and nums2 must exist in the array nums. So the second is that the sum of the numbers of the set bits in nums1 or nums2 and nums1 and nums2 is greater than or equal to k, where or is the bitwise or, at and is the bitwise add. So what is this meaning? Let me just use an example. So for example, 2 and 3. So what about the 2 and 3? 2 and 3, this is a 1 0 and 1 1. So 2 and 3, the set bit, it is 1 0, 1 1. So the final result is going to be 1 0. So the set bit is 1. So what about the 2 or 3? So in Python we're going to use a pipe as all. So 2 or 3, so it is this 1 0 and 1 1, but it will be the OR operation, so it's going to be 1 1. So the set bit is going to be 2. So 1 plus 2 is going to be 3. So if the final result is more than or equal to k, basically this is a valid count. So 2 and 3 is a valid count. Yeah. So if 2 and 3 is a valid count, so 3 and 2 will also be a valid count. As we can say, 2 and 3, 3 and 2 going to be the valid count. But exactly how can we solve the problem? Yeah, this problem it's not so. I don't think it's so easy to think about the solution. So the idea is that how can we turn this kind of formula, nums1 or nums2 and nums1 and nums2 together, instead of calculating them separately, so we're gonna calculate them together. So this means what if we turn the two numbers into a set? So for example, this is 2 3 1 0, and for 3 it is 1 1. So if we turn that into a set, maybe it is possible to solve the problem. Yeah, if we turn it into a set, this is 1 0. So from let's just use numbers to represent the set. Maybe we're starting from 0. So this is a 0 1. So here also starting from 0 1. So for this number 2, we're gonna call it as set 1, and for this number 3, we're gonna call it as set 2. Yeah. So inside set 1, we are having this kind of set. So inside the set, because this is 2 or 3, so it is the OR operation. This means we're gonna combine them together. So it's gonna be something like this. Yeah. So if it is 2 or 3, as we know, the result is gonna be 2. Yeah. So what is 2? So for 2, we have 0 1. So here, yes, for 3, yeah. So for 2, as this is a 0 and this is a 1, this means for this 2 we have a 1 but we don't have 0. Yeah. So we're gonna put a 1 here. It means this is for set 2. So we have a 1 but we don't have 0. But similarly for this 3, it means we have a 1 and we have a 0, right? So yeah. So this is a 0 we have, but we still have this number 1. Yeah, so this number 1 is also here. Yeah, so basically if we make a drawing, it's going to be 2 result if it is the OR operation. So if we make a drawing, this is a set A and this is a set B. Yeah, so this is, if it is the OR operation, it means all those numbers will be included for A and B. So for A, we're gonna call it is number 2. So it means we have a number, it is 1. But for B, we're gonna call it, because B is 3, 3 is 1 1. So it means we have a number of 0 and 1. So if we turn the binary numbers into a set, so definitely we're gonna use the set operation to solve the problem. What is A or B? A or B is gonna be 2. There are gonna be 2 numbers. What is the A and B? A and B, they're gonna be 1 numbers. So 2 plus 1 gonna be 3. So this is 3 going to be exactly a plus b. This is the set A, and this is the set B. This means the number, how many numbers inside set A, how many numbers inside set B. It's going to be set A plus set B. Yeah. So this is all. As we can see, yeah, if we use all, this is the whole areas we calculated. But what is the add? If we use A and B, this is the areas exactly we calculated. For all, this is all the areas, right? Yeah. If we use A or B plus A and B, it's going to be exactly like A plus B, set A plus set B. Yeah, because this areas, there's only one duplicate areas. Now, we plus this areas, we're going to have two duplicate areas. And if we split it apart, it's going to be something like A and B. This is A, and this is a set B. So this means, yeah, we can directly use set A plus set B to check how many different combinations. Yeah. So to solve the problem, we're gonna directly turn the nums into a set. So yeah, because if there are duplicate numbers, it doesn't matter. For example, there are 2 1, this one and this one. It doesn't matter because definitely we're gonna have 1 3, and we cannot have duplicate. So this means we're gonna turn the nums into a set. And secondly, we're gonna find all the nums inside the set. But we're gonna use the bit count. We're gonna check how many bits, how many set bits, bit count for inside the set nums. Yeah, so let's just turn this into an array. And this is our new nums. Yeah. Yeah, so we're gonna use the set bit, because if the set bit is different, definitely it means we're gonna turn those set bit into numbers. And now, as we use a set of nums, this means all the numbers inside of the nums going to be unique. So if it is unique, it doesn't matter. We just need to count how many set bits, and then we're gonna use the set bits to represent how many numbers inside a set. So for example, this is our set bit. It means in our set we have 0, 1, 2, 3. We're gonna just use it to solve the problem. For example, for another one, it is 0, 0, 0, 1. So this means inside the set it's gonna have a 0. So this means A or B, it's going to be 0, 1, 2, 3. A and B, it's going to be only 0. So how many of them? It's going to be 5. Yeah. So this is why we're going to directly use the set bit to solve the problem. But for this one, we're going to use a counter. So we're going to turn this array into a counter, and then we're going to directly use the counter to solve the problem. We just need to find how many different combinations. Yeah, actually it's going to be 2 parts. The plus operation of 2 parts. So let's just use k1 v1 in d.items, and for k2 and v2 in d.items. Now we can directly use k1 plus k2 if it is more than or equal to k. Yeah, this means definitely, because this is actually the formula what we got. We just need to check how many set bits. If the set bits is 7, maybe this set bits is 8, or this is set bit is 7. It is still okay, because 3 and 3 in this example, it is still okay. Yeah. Yeah, but the numbers are gonna be different inside this v1 and v2. Yeah. So if v1 equal to 1, this means this number, oh, there's only one different kind. So for example, they're gonna be different. This is 1, 1, 0, and this is 0, 0, 1, 1. Actually, we're gonna put it inside the v1 or v2, because yeah, it only have 2 set bits. But while for our calculation, it's gonna be different. We can directly use k1 and plus k2. If it is more than or equal to k, we're gonna update the result. It's gonna plus equal to 1, and finally, we're gonna return the result. Yeah. So the result is gonna be 0, but actually it is not 1 because it depended on this v1 and v2. It's gonna be v1 times v2. Yeah, so this is only different, because for this v1, if it has two numbers as I explained earlier, for example this one, it's going to be 2 different combinations, and for this v2, maybe this is a v1, it has 2 different combinations, maybe v2 have 3 different combinations, and then we're gonna just, if it is valid, it's going to be v1 times v2, it's going to be 6 different combinations. Yeah, I hope you understand why we're gonna use the times operation. Now let me just run it to check. Let me just refresh. Yeah, now I think I can submit it. Now let me just run it to check if it works. As you can see, it works. Now let me just submit it to check. As you can see, it passed for testing cases, and it's pretty fast. Because the time complexity here, it is only something like 30 times 30. It is the log of this numbers. Yeah, it is the log of this numbers 10 to the power of 9. We're gonna turn this one into a counter. So the time complexity, the maximum of this number, 10 to the power of 5, and 30 to the power of 2. So this is going to be the final time complexity. So we're going to say it's going to be the time complexity going to be O n going to be length of the nums array. I think that's all about it. Thanks for watching. See you next time.